There's lots of products that promise to boost our immune system, and who wouldn't want that? Well, there's millions of people with autoimmune diseases, inflammatory diseases, and allergies, right? Millions of people whose immune systems may already be a bit too active. I try to make sufferers of seasonal allergies feel better by explaining that having an overactive immune system is not all bad. Individuals with allergies have a decreased risk for cancer compared with the general population. Yes, your immune system may be in such overdrive it's attacking things left and right like tree pollen, but that heightened state of alert might also help bring down some budding tumors in the body. So it's tricky. We want to boost the part of the immune system that fights infection, while downregulating the part that results in chronic inflammation, and mushrooms may fit the bill. There are thousands of edible mushrooms, though only about 100 are cultivated commercially. Only 10 of those really on an industrial scale, and I do mean industrial, rising to over 20 million tons, and for good reason. They accelerate immunoglobulin A secretion. Let me explain. Though skin is considered our largest organ, we actually interface with the outside world more through our mucous membranes that line our mouth, our entire digestive tract, our reproductive and urinary systems, inside the breast glands, on our eyeballs, occupying our largest body surface area. Our gut alone covers more area than a tennis court, and much of it is only one cell thick. One microscopic layer is all that separates us from all the toxins, viruses, and bacteria out there, and so we need one heck of a first-line defense. And that defense is called IgA, immunoglobulin A. Immunoglobulin means antibody. These are our type A antibodies. Dietary intake may improve mucosal immunity by accelerating IgA secretion, but no studies have ever been conducted on mushrooms until now. So they had half people eat their normal diet, half eat their normal diet plus cooked white button mushrooms every day for a week, then using the passive dribble method for collecting saliva, they just measured the amount of IgA they were pumping out. No change in the control group, but after a week of mushrooms, IgA secretion jumped 50%, and even stayed up there for a week after they stopped eating the mushrooms. This study has shown, for the first time, that dietary intake of white button mushrooms, just regular white mushrooms, about a cup a day, resulted in higher IgA secretion, and the elevated secretion remained stable into week 2, but then fell back to baseline. So this suggests that in arresting or slowing the decrease in IgA in individuals such as the elderly or those with immune compromise, a continuous daily intake of mushrooms may be necessary to maintain an increased IgA secretion, meaning you can't just eat mushrooms once and expect to be protected forever. You have to make them part of your regular diet. But if you continue to churn out 50% more antibodies, might that contribute to chronic inflammation, which is implicated in the development of a variety of diseases? No, in fact, mushrooms appear to have an anti-inflammatory capacity in vitro, suggesting that they could be regarded as a potential source of natural anti-inflammatory agents. For example, here's an inflammatory response without mushrooms and with mushrooms, right? Both white and a few other varieties. They think it might be the phytonutrient pyrogalol, found in a variety of mushrooms, as well as in our old friend amla, Indian gooseberries, that similarly appear to reduce inflammation while at the same time boosting immune and anti-cancer function. As we age, our immune system starts to decline. That's why when you hear infectious disease advisories, they often list those at greatest risk include infants, the immunocompromised, and the elderly, because the elderly are, to some extent, immunocompromised. Recently, researchers in Belfast reported an investigation into the possibility that inadequate diet may be a contributing factor to immunological aging. Both immunity and fruit and vegetable intake can be low in the elderly, so they wondered if there might be a connection. So they rounded up 83 volunteers between 65 and 95 years of age, and randomized them into the control group following their pitiful 2 or fewer servings of fruits and vegetables a day diet, versus the experimental group that were told to consume at least 5. They did this for a month before they were due for their pneumonia vaccine. The experimental group didn't quite hit 5 daily servings, but at least they did better than control group. Here's what happened when they were given Pneumovax. Here's the immune response in the control group. They were injected with pneumonia bacteria vaccine. Their immune systems should have gone crazy making antibodies to fight off the perceived invader, and they tried their best. But this is the group that was on almost 5 servings of fruits and veggies every day for the prior 4 weeks. Influenza and pneumonia constitute the 7th leading cause of death for our elderly. It's never too late to start eating healthier. What we eat, or don't eat, can affect our immune system. This study was conducted to determine the effect of the consumption of brightly colored vegetables on the immune system. The first 2 weeks, basically no fruits and veggies, then 2 weeks drinking a cup and a half of tomato juice every day, then carrot juice, then spinach powder. This is a graph of a marker of immune function over those 8 weeks. Within just 2 weeks of a fruit and veggie deficient diet, immune function plummets. But just a cup and a half of tomato juice and can bring us back from the ashes. Not 5 servings a day, just that 1 tall glass of tomato juice. But the carrot juice alone didn't seem to help as well, nor did the powder equivalent of about 1 serving of spinach. This says to me 2 things. 1, how remarkably we can affect our immune function with simple dietary decisions. And 2, not all veggies are alike. Though this study was repeated looking at other immune markers, and the tomato versus carrot appeared more evenly matched, there is one family of vegetables we definitely don't want to miss out on. Inflammation, leaky gut, all because of an absence of AHR ligands. In other words, an absence of cruciferous vegetables in our diet: cabbage, collards, cauliflower, kale, Brussels sprouts, broccoli. So, do people who eat healthier actually get sick less? Those who eat more fruits and vegetables appear to have a lower risk of getting an upper respiratory tract infection like the common cold, whether they're otherwise vegetarian or not. Even just 1 added apple a day may help keep the doctor away. The common cold is so innocuous, though. Why not test against something stronger? One can also look at more serious respiratory infections like influenza. Looking at the relationship between various risk factors and influenza-related hospitalizations in the United States, they found that a 5% increase in the prevalence of obesity was bad, associated with 6% increased hospitalization rate, but physical inactivity was worse, 7%. But just that tiny bump in the rates of low fruit and vegetable consumption may increase flu-related hospitalization rates even more. And the common cold isn't always innocuous. A common cold during the first trimester of pregnancy is associated with a number of birth defects, including one of the worst, anencephaly, a fatal malformation of the brain. More recent data suggests it's the fever, as anti-fever drugs appeared able to prevent the possible birth defect-causing effect of the common cold. But even better, to not get sick in the first place. 1,000 women and their diets were followed before and during pregnancy, and women who consumed more fruits and vegetables had a moderate reduction in risk of upper respiratory tract infection during pregnancy, and this benefit appears to be derived from both fruits and vegetables instead of either alone. Whole fruits and vegetables provide a natural balance of all sorts of things that may improve our immune function in a complementary, combined, or synergistic manner that could account for the protective effect observed from high consumption of both fruits and vegetables. Or maybe that's the only way they got enough. The women who appeared protected in this study were eating nearly 9 servings of fruits and vegetables a day, compared with only 5 servings of fruits or 4 of veggies. That may fulfill some arbitrary 5 or 6 a day minimum, but may be insufficient for effective immunity. For example, in that famous study I profiled previously, elderly individuals randomized into a 5-a-day group did have an improved antibody response to their pneumonia vaccination, compared to just 2 servings of fruits and veggies a day, an 80% increase. But only 30% reached their target levels, 12 out of 40. 6 times better than the 2-a-day group, but maybe 8, 9, or 10 a day would have worked even better. The belief of green tea as a wonder weapon against diseases dates back thousands of years. I've talked about it in relation to chronic disease, but what about infectious disease? Interest in the antimicrobial activity of tea dates back to a military medical journal in 1906, suggesting that servicemen fill their canteens with tea to kill off the bugs that caused typhoid fever. However, this effect of tea was not studied further until the late 1980s, when tea compounds were pitted against viruses and bacteria in test tubes and petri dishes. But what we care about is, do they work in people? I had dismissed this entire field of inquiry as clinically irrelevant until genital warts. External genital warts, caused by human wart viruses, are one of the most common and fastest-spreading venereal diseases worldwide. Patients with external genital warts present with one or several cauliflower-like growths on the genitals and/or anal regions, considerably impairing people's emotional and sexual well-being. But rub some green tea ointment on, and you can achieve complete clearance of all warts in more than 50% of cases. Wow, if it works so well for wart viruses, what about flu viruses? Works great in a petri dish, but what about in people? Tea-drinking school children do seem to be protected, but you don't know until it's put to the test. If you give healthcare workers green tea compounds, they come down with the flu about 3 times less often than those given placebo. In fact, just gargling with green tea may help. While a similar effect was not found in high school students, gargling with green tea may drop the risk of influenza infection 7 or 8-fold compared to gargling with water in elderly nursing home residents where flu can get really serious. Unlike antiviral drugs, green tea appears to help by boosting the immune system, enhancing the proliferation and activity of gamma-delta T cells, a type of immune cell that acts as a first-line defense against infection. Subjects who drank 6 cups of tea per day had up to a 15-fold increase in infection-fighting interferon production in as little as 1 week. But why? There's actually a molecular pattern shared by cancer cells and pathogens, and with edible plant products such as tea, apples, mushrooms, and wine. So eating healthy foods may help maintain our immune cells on ready alert, effectively priming our gamma-delta T cells that can then provide natural resistance to microbial infections and perhaps tumors. I guess I shouldn't have been so surprised. Tea, after all, is a vegetable infusion. You're basically drinking a hot water extraction of a dark green leafy vegetable.